everyone, and welcome back to the Philosophical Jew podcast. I have on with me today the co-host of the Physics to God podcast, a truly unique podcast in the philosophical sphere and in the scientific sphere, a podcast speaking about why current matters in physics point to an intelligent creator and point to God. It is a truly fascinating journey, and it is spearheaded by the co-hosts, the guests that I have on, Rabbi Feder and Rabbi Zimmer. Rabbi Feder and Rabbi Zimmer, would you please tell the audience a little about yourself?
Sure. Pleasure to be here. I'm Rabbi Feder, Elie. You can call me Elie. So I'm a modern Orthodox rabbi, and I'm also a math professor. So I grew up in a modern Orthodox home, which had a strong value of both Torah, religion, and of science. And my grandfather is a rabbi and a chemist. My father is a rabbi and a lawyer. And basically, I grew up as with a strong focus on both. It was natural for me, being a math guy. It was just natural for me to go into math. And sure enough, I ended up getting a PhD in math. And now I'm a professor in a local college in New York. And I give a shiur. I'm going to teach Gemara and Chumash. And the two of us, we have this podcast, Physics to God. And we've been working on it in a bigger way for about 10, 15 years, but the podcast for the last 2 years or so.
Okay, and my name is Rabbi Aaron Zimmer, but you call me Aaron. And also I'm an Orthodox rabbi. I got a college degree in physics, and then I got smicha after that. And I've spent a lot of time trying to synthesize different areas of thought. In particular, I'm always interested in the seeming conflicts between religion and science and finding ways to reconcile the two and see how, in fact, one can enhance the other. That's obviously part of the Physics to God podcast. Even though we don't deal with religion, we're dealing with God and philosophy and science. And it's an attempt to really create some sort of unity and remove the apparent tension that people in the modern world feel sometimes is presented by the secular, scientific world to the religious beliefs. I was a commodities trader for like 11 years. And now basically, we make this podcast and we try to teach people about the ideas of, one God and how science can help support and really give a foundation for the idea of God.
Yeah, that's really amazing. I wish I had that growing up. My father was always a bit of a physics junkie. He's his profession is in the maths. I did not inherit that gene, but I'm trying to follow in his footsteps a little bit there.
Okay, listen, you should know Aaron's the complicated physics guy, and he says it as it is. But my job is to help people like you who aren't necessarily well versed in physics, or sometimes I have a lot of students who are afraid of math, and so that's part of our. We're not talking only to physicists or people who have backgrounds in physics. We're trying to bring these ideas to the philosophical Jew.
Thank you so much. Yeah, and for those of you, I don't know if I made this clear earlier, but the Physics to God podcast is actually also a YouTube channel. And when I watched the first season, which deals with the intelligent creator, the animations in the podcast, especially the revamped ones, really, really helped me out. So I was really just kind of blown away by how much I understood, despite how much I feared not being able to understand. So it was a really well done job. And I think you have season 2 out now, Multiverse. Is that correct?
Yeah, we have season 2 on YouTube. Only the first few episodes are. We're releasing them slowly, but on the podcast, if you listen to them on Spotify or Apple, you can get the whole season 2. But in terms of the videos, which does help a lot of people, some people are visual learners, some people are audio learners, some people like to read, but it depends how you process information, really. But on YouTube, it's only partially out, but it will be completed over time.
Sounds great. Looking forward. Speaking of being an audio, visual, and somebody who reads, depending on different learning styles, you had a Daily Wire article recently saying how physics points to God. And so in the recent Daily Wire article, you actually emphasize that physicists have identified around 25 fundamental constants, like the fine structure constant and the cosmological constant, at roughly 10 to the negative 122 degrees, whatever that means, to the negative 122nd power, whose precise values allow atoms stars, and life to exist. Could you explain what it means for these constants to be fine-tuned, and why even minute deviations would render the universe uninhabitable?
Sure. So let's take a step back. Before we talk about the constants being fine-tuned, we have to talk about the constants. What are the constants? And the constants go back. There's nothing to do with fine-tuning. Fine-tuning is a discovery that is more recent, but the idea of constants is part of fundamental physics. And the goal of fundamental physics is to explain everything which we see around us and break it down into its simplest, most basic building blocks. So we think of everything as built out of like elementary fundamental particles called like electrons, things like that. And then we try to understand the underlying laws which govern the interaction of these fundamental particles, like gravity, for example. And the idea is that when physicists are looking to get simpler and simpler down to the core foundations of our universe. And when they've got down to it, they've discovered, they're doing great. They've discovered basic fundamental particles and the laws which govern them. But the laws and the particles have these numbers that are built into them. Okay, so besides for the laws, let's say gravity, the two masses attract, there are also constants. There are numbers. So an electron is let's say two electrons repel, but there's a number called, as you mentioned, the fine structure constant, which determines the strength of their interaction. And that number is like 1 over 137.0359999139. These are numbers, and there's 25 or so numbers that are built into the fabric of our universe. These are numbers that physicists measure. They can't figure them out based on any calculations. They simply measure them experimentally. And they're numbers that are baked into the fabric of our universe. Okay? And that's this idea, the constants of nature. Scientists were long bothered. How do you explain these constants? Physicists want to explain everything. They want to get simpler and simpler. How do you explain the core fundamental elements of our universe? And Richard Feynman called this one of the greatest damn mysteries of physics, to explain what these numbers are. What's the cause of these numbers? Where did these numbers come from? Physicists didn't think you'd find this at the core of our universe. And this leads to this great mystery. Want to talk about the mystery?
Sure. The mystery is really, it's an abstract idea. Before you get to fine tuning, is the difficulty that you might have in trying to explain a number. So how would you explain if somebody just told you how big an electron is? So say, why is it that big? What makes it so heavy? Every electron has the exact same, strength, the exact same weight. Or when two electrons interact, it's always the same force between them of pushing apart. And it has to do with the probability of interaction. But it's determined by a number, and the number is the fine structure constant's 1 over 137 point something, right? So where does that come from? So it's the mystery is, how do you explain that number? And right away, you're really presented with only two real possibilities that jump out at you. And this is going back, 40, 50 years, or even really 100 years of fine structure constant. One is just to say, look, these numbers that's just the way it is. It's just the reality is the way it is. It's a brute fact of reality. You can't really ask why these numbers are this way. That is the way it is. And now that's not beautiful. It's not really simple to say the reality is 25 arbitrary numbers and just these, unwieldy, random looking numbers. But it's a logical possibility just to say this is just of necessity, the reality, the universe has to be this way. But you would like to explain it on a deeper level. That's what at least Richard Feynman thought all good theoretical physicists should do. You might say, well, maybe there's some deeper qualitative law, mathematical law, where just of a necessity, it determines that the numbers must be that way. But how can you find a law like that? Where are you going to find a theory, a qualitative theory, which doesn't have any quantities and numbers put into it, which just pops out these numbers? And that was, it's another logical possibility. And I guess that law would be some necessary, has to be that way. And it would just determine these numbers. And it just seems highly implausible that physicists would ever come up with that. And that's why Richard Feynman called it one of the greatest mysteries in physics. That was 40 years ago he did this. And it was it was a mystery. And at that point, and then that's really right before fine tuning. At that point, it doesn't make sense to say, well, God made it that way. I know, people, you might think, well, why can't you say God made it that way? That would be God of the gaps, just to say that we have this big mystery of 25 numbers, fundamental numbers, irreducible, can't be determined by anything else. And I would just say, well, God made it that way. Well, that's just replacing one mystery with another. You just say, well, why do you gotta make it that way? And what about the numbers points to God? It's just you have a big hole in your science, your knowledge of science, and you're saying God. That doesn't really answer anything. That just begs the question. It's just filling in one question mark with another. Well, what does that even mean? That would be an argument from ignorance, and that's why you don't want to say at this point God did it. You really want to wait and see. The proper scientific methodology is: will science discover some scientific knowledge and understanding about these numbers that will allow you to make sense of them and to explain them and to tell us why they are that way? Why, how do you, and that's the mystery, and that's the method of waiting and seeing. And that's exactly what scientists did.
So let me just give an analogy which will help introduce the idea of fine-tuning. So imagine you had an ethical system, and your ethical system had a bunch of laws of ethics. And one of the laws, and you're trying to explain, like, what's the underlying basis for the system of ethics? And maybe you had some principle: do unto others as you want done to yourself. But then let's say you had a particular law in this ethical system that you have to give charity. That makes sense. And the percent charity, you have to give 13.8743261%. That's strange. That would beg the question, how do you explain that number? Is that number just plopped in there? Is that somehow result from some previous law that just pops out a number like that? It's a great mystery. How do you explain a number? So just like in an ethical system, you would have a hard time explaining a number like that. In physics, the same thing is the case. You want to explain the mystery is how do you explain the emergence of a number as such? Okay. Now, what scientists discovered is, and this was to their surprise, was something called fine-tuning. So let me talk about fine-tuning in the framework of this analogy, and then Aaron will explain how it expresses itself in physics. So we imagine in this society, we were to do some sophisticated economical calculations, and we discovered that this number is not any random number, 13.8743262%, but it's very specific. And that is, if the number were any smaller by a little bit, then we'd find that poor people would starve. They wouldn't have enough money to live, to put food on the table, and it would lead to the class warfare. The poor people would rebel and overthrow the whole society. And therefore, it couldn't be lower than this number. At the same time, then we would look, well, maybe it could be higher. And let's say we did, again, some rigorous economical calculations and realized that if it were higher, then rich people would say, listen, it's not worth it for us to work. We're putting so much time and energy into working, and you're making us give so much charity. It's just not worth it. And then it's going to kill the productivity of society. And let's say economists were to discover that this number is exactly in the sweet spot, which is necessary to motivate wealthy people to work, and at the same time to give poor people enough money to be able to put food on their table. That would be a discovery that this number is fine-tuned. And that would be an explanation. You would say, wow, that's interesting. That number is not as arbitrary as we thought. It has a very specific value for a specific purpose. Okay, so physicists discovered that's actually the way it
maybe before we do that, maybe just take a step back. Do you have any questions about the mystery of the constants, what the constants are, and why they're so difficult to explain? Does that make sense to you?
Yeah, so essentially from what I picked up is that decades ago, right, science was discovering that there was a certain formulation at the fundamentals of the universe, a certain calculation that happened that we just realized this is the approximate size function of certain numbers, and we didn't really know why. It was sort of just there. But then once scientists actually tried to, maybe manipulate the numbers a little bit, they actually said oh wow, these numbers are necessary in some sense. It couldn't have been any other way.
So that's what I'm saying. Let's take a step back before you manipulate the number. That's why it's before you manipulate the numbers. So just two things on the is one is it's not a calculation. Scientists didn't calculate these numbers; they just measure them. There's no way to calculate the numbers. That's part of what's so mysterious about them, is you can't calculate them. You just measure how heavy an electron is. It's that heavy. You measure the force. How strongly do two electrons? They both have charges. They repel each other. Or an electron and proton. How strongly they attract to each other. Electric charges are opposite attract. So how strongly you can measure? It's just you can find tools Like you can measure anything. You can measure tiny things, you measure big things. Let's like put an electron on a scale or measure the force, how hard it's pulling. So you don't calculate these numbers. And again, the numbers just to so your listeners understand what these numbers are, how they fit into physics. It's just they're quantities in the universe. It's like in any area, in any system, you have to just like Elie's analogy, you have to give charity. So many money give to poor people, but how much? So charity is a qualitative idea. Some of your money keep for yourself, some of it you give to others. But then the question is, how much do you keep for yourself? How much do you give to others? So that's quantities. And in the universe, in physics, everything is qualities and quantities. You could say there's such a thing as an electron as a charge, but how heavy is an electron? How much charge does it have? So these numbers are the numbers that determine the quantities of the universe. And the mystery is, how do you explain them? So that's
so they were there to be discovered. Sorry to like interrupt. They were there to be discovered, not actually sort of imposed by scientists. Like they were there already to be discovered.
Yeah, to be discovered just by measuring. And you want to measure how big is how much does an atom weigh? How big are these things? How strong is gravity? You know what I'm saying? It's how fast. If you jump off a building, how fast are you going to fall to the ground? I mean, that's just how fast. It's how much. It's all quantities. There's everything in the world has quantities. Yeah, it's very, and they're and these numbers they're just given. They're just facts of nature. And the question is, how do you explain where these quantities come from? Because they seem to arbitrary random numbers. And that's the mystery. How do you explain it? Are they just the way that is, or is there some deeper theory to explain them that makes them that way? That's the problem, the mystery.
Thank you for clarifying that nuance. I think I have to admit I missed that nuance. That's actually very, very fascinating. That they were just sort of there.
Yeah, they're just measured. They're just measured.
Wow.
If Feynman has this thing of like it says if the hand of God wrote them in, and we don't know what kind of dance you have to do in order to get them to pop out. It's just it can't be calculated, it can't be derived. They're not. They're fundamental, meaning they're not derived from anything else. They still are the fundamental constants in nature because they have no further cause, in the scientific framework. Okay. So then this is what I was about to get to, or it was the analogy, is the key point is that the mystery of the concepts of explaining them is based on the assumption that they're arbitrary random numbers. And then it's just like, well, how do you explain a random number like that? 1 over 137. But what fine-tuning shows us is that the numbers are not arbitrary. They're not random numbers, but they are the exact precise numbers that are needed in order to get a universe that has atoms and molecules and planets and stars and galaxies and life. So, for example, if the fine structure constant was a little bit bigger, then atoms wouldn't be stable, or stars wouldn't exist. Stars are a balance between electromagnetism and gravity, and if you change these forces, changing the strength and the relative strength of these forces, and then you wouldn't have stars. And stars are necessary for pretty much everything. They besides producing light and heat, but they also produce all the heavier elements beyond hydrogen and helium. And it was really, it shows you the numbers really aren't random, but they're precisely set within small, narrow ranges that allows a complex structured universe to exist with all these different structures of, stars and planets and galaxies. And slowly but surely, it really started in the 70s. That was the first time somebody had this idea. I think it was Brandon Carr, maybe. But then over time, it became more and more of these numbers were discovered that they're not just random arbitrary numbers. They have to be in this range. And it was really in 1998 with the discovery of the cosmological constant, which is this incredibly tiny number, and it controls the expansion rate of the universe, like how quickly the universe expands. And it was discovered. It was initially thought that the expansion was just from the initial Big Bang. It was expanding. And the cosmological constant, which would cause that to accelerate or decelerate, was 0. People assumed it would be 0 because 0 is a number you can explain pretty easily. It's just not there, or there's something, two things cancel, or whatever it is, 0 you can explain fairly easy in a qualitative sense. But it was discovered that it's this incredibly tiny number, which is, with basically a decimal place, a decimal point, and then 120 zeros, and then like a 3 or a 1 or whatever it is. It's incredibly tiny. And if it was a few zeros more or less, then the universe would have either expanded way too quickly, and then no structures could form, no galaxies, nothing, no stars, everything would have ripped itself apart if it was a little bit bigger, or if it was a little smaller and negative. It's this tiny little number, a positive number, really small. If it was a little bit smaller than that, a negative, the universe would have collapsed in on itself right after the Big Bang, and just there wouldn't have been a universe. Basically, it would have collapsed right away. And that's when scientists realized, okay, this is serious. Fine tuning is a real thing. It's not, because you could have just said it was all just random chance and lucky. We just got lucky. You know what I mean? These numbers were just randomly set by whatever chance. We live in a big casino, and we got lucky. But if it's off, that's only for like some of these numbers off by 1%, 2%. Things don't work. But by structure constant, it's fine tuned to 120 decimal places, or at least 90 decimal places. So what the odds of getting that by chance alone are 1 in a trillion. It's just not reasonable to get lucky like that. By chance, if there's one universe and we got lucky. So that's when scientists realized fine-tuning is a real thing. And fine-tuning really, when you think about it conceptually, it really solves the mystery of the constants. It shows you a different way to explain why these are the numbers. So
right. So again, just going back to this analogy, if we really discovered that the charity rate of 13.87 whatever percent was necessary for our society to be stable, that would point to the fact that this number wasn't just an arbitrary random number, but it was a number which was set for a purpose. And that purpose was to produce a stable society. And analogously, even though Feynman had a mystery, how in the world do you explain these constants? That was under the assumption that they were just random arbitrary numbers. But once they realized that these numbers were specifically tuned to produce an ordered, structured, complex universe, that points to the purpose of these values. And when you see a purpose, when you see a cause that has a purpose that acts towards a future purpose, that indicates an intelligent cause. So the idea is that physicists usually explain causes based upon the laws which bring these phenomena into existence. So you see phenomena now, and you see the laws which brought it into existence. And those laws don't act with a purpose. They're just mathematical formula which pop out certain results. But here you see a cause which acts forward-looking towards a purpose, towards bringing about a universe. And that's the mark of intelligence. An intelligent act or intelligent cause is one which selects one choice from amongst many for the purpose of bringing about an intended goal. And the cause here, God, selected the particular values of these constants from all the possibilities so that they will yield a universe which is much greater than the sum of its individual parts. The constants align all towards bringing about our complex, amazing universe, which is filled with structure and order on all levels of complexity. So that's the basic argument.
Yeah, that's a very brilliant way to point to an intelligent creator. Very well said. Just to emphasize, because I think that it might be lost if we're sort of just listening haphazardly to the paradigm shifting notion that you just described, is that essentially our entire universe, right? Not just Earth, not just our galaxy, every single constant is itself such a low chance of happening by accident, so to speak. And there's 25 of them, and they each point to something placing them there on purpose for a future goal. And it's just, I feel like it's lost on people when pondering just how vast and how mysterious the universe is. Chance is sort of an easy explanation because like it all just sort of happened, but when you think about it this way, it's an unbelievable paradigm shifting notion. And really,
one thing is it's not all 25 of the numbers. It's like 10 or 12 of them that you can show. If they're a little bit bigger, what will go wrong? If they're a little bit smaller, what will go wrong? So it's like as science progresses and we learn more about the universe and how stars work and how planets work and how dark matter works and galaxies form, then you could say, oh, now I see another fine tuning. I could see what will go wrong if this constant, like the mass of a quark or something is different. So it's as science discovers more and more, they start to realize more and more of the constants are fine-tuned. Enough of them are fine-tuned that it's not plausible to explain it by chance alone. Even just one of them, you can't explain by chance. It's so unlikely. but certainly not 10 or 12 of them. But it's not all 25. It potentially could be all 25, but in order to really show all 25, science would have to get even more knowledge and understand more about the universe. And then we'd say, wow, this number, which we thought could have been in a bigger range, it has to be even a smaller range,
Mm-hmm.
So it's not all 25. And you don't need, for the argument to be that these constants, we have an explanation, you don't need to show all 25 are fine-tuned. It's enough to show that's generally true about the constants, and it gives an explanation of why they are these numbers. And the other ones, either they don't, it's possible some don't matter. I doubt that, but you can just say, look, we're lacking knowledge to see just how fine-tuned they are.
Right. Just to add a point is that once we discovered fine-tuning, the previous approaches to explain the values of the constants became unreasonable. For example, just to posit that the numbers just are brute facts. That was what someone may have thought when it was just a mystery. Why these numbers? I don't know. Maybe that's just the way they happen to be. But now you're going to have to say they happen to be these numbers that are baked into the universe, and those are the numbers which coincidentally result in our unbelievable ordered structured universe. You'd be totally ignoring the clue which we've discovered that these numbers are fine-tuned. Also, the whole, maybe we're going to discover a formula, a law, which is going to pop out these 25 numbers. That was far-fetched before they discovered fine-tuning. But now that we discovered fine-tuning, to hope that we're going to say, you know what, I don't like fine-tuning, forget that. I'm going to hope that I'm going to find a law that's going to explain where these numbers come from. That would be just ignoring the discovery of fine-tuning. So once scientists discovered fine-tuning, no one is anymore hoping we're just going to happen to find the law, or these are just fixed given realities of our universe. That's not really a reasonable way to explain the constants anymore. You have to explain the constants in a way which acknowledges the new discovery, the knowledge of fine-tuning. And that's why you need God or scientists' alternative, which I guess we'll get to. Multiverse.
Yes, thank you for those important clarifications. I actually think you answered one of the questions I was going to ask you, so I'll skip around here a little bit. You write about the constants that it's kind of like finding a safe with a trillion-digit combination already set perfectly. That's not something anyone can reasonably attribute to blind chance. Can you elaborate on why an alternative hypothesis to fine-tuning, right, the multiverse hypothesis, which posits an infinite amount of universes, or the hypothesis being intelligent cause. Can you elaborate on why a multiverse hypothesis would be blind chance? It would seem that in an infinite amount of universes, the chances aren't so much blind as they are inevitable. So I'm curious as to what your take is on that.
Okay, so let's go slowly here. So the question is, how do physicists get around this problem? Okay, how do the fact fine-tuning, we're saying, points to intelligence? How do you explain fine-tuning if you don't posit God? Okay, so the idea is a multiverse. The multiverse has really three components. I'll talk about the first two for now. The multiverse says, imagine, I'm saying this, if we only had one universe, everyone would agree that the odds of our numbers being so perfectly right by chance alone is ridiculous. It's not a reasonable way to explain the numbers. But let's imagine there really are infinitely many universes out there. So everything we see is one universe. Everything we see has constants are fixed, but everything that's one universe. Imagine there are infinitely many such universes. And in all these are like parallel universes that we can never ever observe. But let's imagine these all exist. And imagine these different universes are not identical to ours, but they change. So the constants, for example, in our universe is 1 over 137. In the other universes, it's 1 over 150. Another one is 1,000,000. Another one, whatever. Imagine the constants in all these different universes take on all the different values. Now, if you would do this in this set of infinitely many universes, you're going to automatically have some universes, even infinitely many of them, which happen to be fine-tuned just by chance alone. And if you'll ask, well, what are the odds that we happen to exist in such a universe? That's something called an observer bias. Obviously, we couldn't exist in a universe that wasn't fine-tuned. Fine-tuning is a precondition for us to even exist in the first place. So it's not a fair question anymore to say, why do we happen to find ourselves in this universe? So again, if you posit these two premises, first of all, that there really are infinitely many universes, and these universes are varied, their constants vary from universe to universe, then physicists would attempt to explain fine-tuning by saying, that's how we explain our fine-tuned values. it's not a result of an intelligent cause. It's just an absolute coincidence. Okay. A multiverse which explains fine-tuning based upon these two premises alone, we call a naive multiverse. Okay. And their question is, why is that naive? Why isn't this? I guess this is your question. Why? This seems to be a reasonable, good explanation, right? That's basically your question. Why can't we explain these values just based upon this multiverse? Okay.
Well, what do you think about that theory?
The theory of the multiverse?
Yeah. What do you think about it?
I can't say I'm scientifically well versed enough to really make an educated conclusion from it, but I just honestly, I don't know. I can imagine a situation in which a multiverse exists, but to me, like, there are just logical paradoxes with that, not necessarily scientific paradoxes.
Like, what would be a logical paradox?
I suppose you'd have to explain why a paradoxical universe couldn't exist, such as a universe in which the multiverse theory doesn't exist. Right. So I think I actually messaged you about this. So like there would have to be some explanation about why laws are laws. Why do we see any sort of logical consistency across multiple universes, right? Like, I think that's something that would have to be explained.
Okay, well, they would explain, like one of the things we really do on the podcast is we really give scientists a fair shake. We present their arguments fairly and completely, and we always encourage people to, Google the multiverse and fine-tuning, go watch videos from the top physicists in the world, talk about the multiverse and talk about fine-tuning, and you'll see that we present their reviews fairly and accurately. There's no point in us misleading anybody because we'll get caught. So, but what they would say to you is that if it's really a logical impossibility that, you're right, if there's infinite number of universes, everything possible exists. It's true, because there's infinite number and every random combination of atoms will exist. If you try an infinite number of times, every possible scenario that's physically possible will exist, no matter how ridiculous it seems. But a logical paradox will not exist because it's impossible. So there will not be a universe in the multiverse where the multiverse doesn't exist, because that would be a logical contradiction. It would be like if somebody were to say, can God create a rock that he can't lift? Well, that's impossible, because if he could say he can do anything possible, and then could he create a rock he can't lift? Well, that would be an impossible thing for him to be able to do. So if you could create a logical contradiction, God can't do the impossible. God can't cause himself not to exist. That's impossible. So, and that's not a question on the theory about God, because since it's not logically possible, then nobody can do it. It's that which is impossible intrinsically. Nobody has to make it. So God can't do it, and the multiverse can't do it. So any kind of way to knock out the multiverse just by asking a logical contradiction like that is not going to be good enough, because the scientists will just say, you're right. There is no multiverse like that. There's no universe in the multiverse where the multiverse isn't true. There's a universe in the multiverse where everybody believes the multiverse is false. We hope we're in that universe. We hope we're trying to be able to convince people about that. That's our goal, to be in that universe. But that scientists will admit that even if the multiverse is true, there is a universe where everybody believes it's false. But there's no universe in the multiverse where the multiverse actually is false, because that would be a logical contradiction. So that's not good enough to knock it off.
Right. I would counter by the God example, but we don't have to get into the weeds there. I think that the counter implies that the multiverse is some sort of intelligent being itself, but I don't know that you can make that comparison with God. But I hear what you're saying.
Right.
Logical laws would have to be an intelligent being in and of themselves for that argument to work.
Okay.
As in not just observable, but actual, like, intelligent facets of reality. Sorry, we don't have to get into that now. But
okay, but just to
I hear what you're saying, though.
Yeah, just to address another point is, like, according to this multiverse hypothesis, there really are infinitely many universes, and some of them will have laws which are, law-like, and others will just be random, chaotic, or anything which is physically possible will exist somewhere in the universe. So
right.
You're saying is, why do we have to have such orderly laws? Maybe it'll just be chaotic. And who said that in multiverse there's going to be some orderly laws? Well, there are universes in which There's just chaos runs free, So we wouldn't exist in such a universe. We have to be in a universe which has laws and order and structure, and therefore they would explain it as in that manner.
Mm-hmm.
Right. And again, it's you got to appreciate that fine-tuning is such a strong problem that it really points to either God, which scientists do not want to say. They do not believe in God. They hate God. That's just not a possibility. And the only real other way to explain it is a multiverse. And they wouldn't be saying a multiverse if fine-tuning wasn't this compelling argument. On the other hand, these people are geniuses. They're really smart. These are top physicists in the world who are positing a multiverse. Mm-hmm. And it's not so easy to knock them off and just to say there's like some logical, they're not missing logical steps. Like we do knock off we think our season 2, it goes through the multiverse, presents it in a clear way. We explain all the science for any person you're on the scientific background, and we show ultimately why multiverse fails, even the scientist framework. But it's not just some super simplistic argument. It requires real work to, go ahead.
Sorry, far be it from me to like actually argue with you or any physicist knowledgeable in the matter. It was just an off-the-cuff response.
No, I put you on the spot. I asked you. Now I'm going after you. Okay.
Aaron's not really mean.
No, I know.
Okay, fine. Let's give you a little bit of a taste of an approach to knock them off. Okay. Right. And the key thing is, first of all, to realize what's wrong. Why scientists themselves do not believe in just this naive multiverse. That it's sufficient to say there's an infinite number of universes with different laws of nature, and therefore everything possible happens. Okay, so why not? Why isn't that good enough? Okay, so the reason is, and they know this, is that because then there really is everything possible to explain something by just saying everything possible happens leads to absurdities, not logical absurdities, but like ridiculous types of absurdities, because there are universes where, granted, we couldn't exist in a universe without any intelligent observers. If there's no atoms and molecules, you're not going to have any people. That's true. But there are plenty of universes in the realm of everything possible, in which there are atoms and molecules and they're human beings, but there's also dragons and unicorns and magic spells. Again, and there's universes where the sea splits and all the stories recorded in the Bible actually occur. There's universes where a voice comes down from heaven through some quantum wave fluctuation that says, I am the Lord, your God, and you should, multiverse is a false theory. And those all actually exist according to physicists. This we're not making up. This is true. They actually believe that. And that's a problem. That's a problem for them because it becomes irrefutable, a theory that makes no predictions. It just says everything possible exists. And any possible observation could be explained by saying, well, there has to be some universe in the multiverse where there's a voice that's quantum fluctuates, a random sound wave, which says that, God is coming down, and there has to be some universe where the sea splits. And you could explain miracles. You could explain the voice of God. You could explain dragons and magic spells because of random fluctuations can produce anything.
So they call that multiverse of the gaps.
Right. You literally can explain everything. And that's not a good theory. Okay. So the way that scientists get around that problem is they realize that multiverse actually makes a type of a prediction. And that's what saves the multiverse, at least temporarily. Okay, it makes a type of prediction. So go ahead, I'll try to explain this.
So this is what we call the typical universe premise. Okay. And sometimes this is called the principle of mediocrity. And the idea is that if you're trying to explain something by chance alone, so you'd have to expect that you would see the typical occurrence. Like chance makes predictions. You make any random thing. If you flip a coin a million times, chance would not predict that you're going to get a million heads in a row. Chance of prediction, you're going to get like a fair mix of heads and tails. So the idea is whenever you do an experiment, if you're trying to explain something, you have to see what would chance predict would occur. What's the natural, typical observation? And if we see the typical observation, something which would be in line with chance, we say, that makes sense. If on the other hand, we do a process which is supposedly random, and we end up getting this crazy, far out, unreasonable, atypical result, that would be a contradiction to the fact that it's working by chance alone. Okay? So for example, now going to our universe, imagine in an infinite multiverse, there really are infinitely many universes. And there are infinitely many universes which contain intelligent observers. And there are infinitely many more which don't contain intelligent observers. But there is, let's just focus on the set of universes which contain intelligent observers. There are going to be lots of those. One of those might only have a few human beings. One of them may have millions of human beings. The other ones may have millions of human beings on our planet, plus 100 billion galaxies and 100 billion stars each. The idea is there's many different versions of universes which contain intelligent observers. Now, the chance would predict that we would be in the most typical universe which contains intelligent observers. We wouldn't be in a strange, far-out, exotic universe, but we would be in your average, typical universe. And that's what's called the typical universe premise. Multiverse science claim that our universe is the typical universe with intelligent observers. And if that claim is true, then you could invoke an observer bias and say, why do we exist in this universe? Well, because that's what chance would predict. That's a typical universe. Okay. If, on the other hand, our universe is wacky and crazy or is far out, is atypical, then chance, if we would discover that, that would falsify chance as an explanation. Chance isn't good at explaining something which is very, 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 very atypical. So the idea is the claim of this is the third premise, as we call the typical universe premise. Multiverse physicists must claim that our universe is the typical universe amongst universes which contain intelligent observers. That's what's called the principle of mediocrity. We're a mediocre, we're your plain old universe, and this is exactly what you'd expect to find.
Okay. Does that make sense why they have to say that?
It makes sense why they have to say it, but it's sort of making me feel like the multiverse is a little bit less strong.
Okay.
I feel like the claim that we're a typical universe is just, how on earth could you possibly make that claim if there's actually an infinite amount of universes?
Okay.
I don't know. To me, that just
seems it's we are the typical universe that has intelligent observers. That's what they're saying. They know we're not a typical universe. The typical universe doesn't have intelligent observers. The typical universe doesn't have atoms, But of the universes that has intelligent observers, which is universes that have atoms and molecules and at least atoms and molecules, then we are the typical universe. That's the claim. That's still
there's an infinite amount of universes with intelligent observers.
Yes, and different types of universes. Correct.
But is there even an average in an infinite stratum? Like, is that something?
Right. Okay. Good. Okay. Go. Okay. Go.
Do you get what I'm saying? Like okay. I see. Okay. Good. I'm not just making things.
You're good.
Okay, that's really you're heading in the direction right. That's really called the measure problem. Okay, and basically, if there's an infinite number of universes, let's just have an infinite number of universes, then there's an infinite number of every single type of universe. Okay, so then meaning, okay, let's take the two most talked about types of universes. Let's just compare them for simplification. Okay, one way is our universe. Let's just call it our complex structure universe with 100 billion galaxies and human beings, real human beings. The other way to perfectly get intelligent observers, it's called a Boltzmann brain. Okay, and there's scientific papers written about these guys. They're called freaky observers in the literature, and they are just quantum fluctuations of brains, literally, where they just have false memories that they're doing this podcast right now. They fluctuated into existence a few seconds ago, and they're going to fluctuate into existence in a second from now with all the false memories, and it's impossible to really tell whether you're a Boltzmann brain or whether you're a real observer, a normal observer. Okay, and it comes out there's an infinite number of Boltzmann brains in the multiverse, and there's an infinite number of universes just like ours, identical copies. So how can you tell whether you're a Boltzmann brain or you're an actual normal observer? How can you figure it out if there's an infinite number of both? And there really is no simple way to do that because they're both infinite. And that's what you were referring to before. It's multiverse needs to make a prediction, in order to predict what is the typical universe with intelligent observers. But when it tries to make a prediction, it realizes every single universe is an infinite number of copies. Every possible universe exists, and every possible universe has an infinite number of duplicate copies of itself. So how can you really tell what's the most typical? They're all infinitely typical, right? So that's the beginnings of it. In order to solve that problem, scientists have to introduce something called measures. So go ahead, Elie, try to explain that.
Okay, so measures are ways to organize, if you will, the infinite set of universes and thereby enable us to take probabilities. So, for example, let's imagine you had a infinite row of marbles, okay? So you have infinite gold and infinite many silver. And now you want to know, what's the typical marble? Is it going to be gold or is it silver? So you say, well, that's ridiculous. There are infinitely many of both. How would I know what the typical marble I'd expect to predict is if there are infinitely many of each of them? But let's imagine I could order them in my mind, that I'm going to make the row. I'm going to have 10 silver to 1 gold, 10 silver to 1 gold, 10 silver to 1 gold. And it's going to keep going like that forever and ever and ever. In some sense, if I can envision this ordering, then I could say that the odds of predicting a silver over a gold is 10 to 1. And the typical universe, the typical marble would be silver. That's assuming I would envision ordering the marbles in such a manner. And that's what they call like a measure. You can take all the universes out there, infinitely many, yes, there are infinite copies of all of them, but maybe we'll make a measure, which is some sort of a way to organize all these universes and to count them, if you will. And then we could, using such a measure, maybe we could find a good measure which will make it that our universe will be a typical universe with intelligent observers. And these freaky observers, these Boltzmann brains, will be like the atypical golden marble. And if that would be the case, then they would be able to support this typical universe assumption and be able to say, multiverse actually does work out. This is the hope or the claim, the approach which multiverse scientists take to be able to tame the infinities and to be able to actually compute a probability and typicality within our infinite universe.
So what do you think about the measure solution for the multiverse?
You know, I love it. I feel like I'm being interviewed too. It's great. I'm like experiencing it in real time. I mean, to me, like, again, the scientific claim, I can't really speak much to, but the logical problem for me would be like, there's no way to actually ever validate that hypothesis as far as we know. Like we have not made any contact with other universes as far as I'm aware. Like I've tried to, I think like David Deutsch intimates something like that, if I'm not mistaken. Like he's fully convinced of the multiverse, right? Like he's just like, we're all here, we see the quantum fluctuations. Like I honestly, I've listened to many of his lectures. I have no idea what he talks about half the time, just because I'm not like holding. But like to me, there's just, how do you possibly verify that? Like how would you even, not only is verifying the existence of one other universe difficult enough, but to create some sort of order or to impose some sort of order on an infinity, which you can't observe, what you're hypothesizing, it just seems like a reach.
Right.
Right. One thing I just say about the David Deutsch, if you like him, he's talking about the quantum mechanics multiverse, the many worlds interpretation of quantum mechanics. I think in general, that's the multiverse he advocates for. That's really nothing to do with what we're talking about. That's a specific philosophical interpretation of quantum mechanics, where the universe like branches, and every time there's different possible quantum choices. But the laws of nature don't change. Every time a quantum, particle goes one way or the other way, the laws and constants of nature stay the same. So that's the multiverse. That's like, even if you want to believe in a many worlds interpretation, David Deutsch thing, that's not going to help you with fine tuning. The only type of multiverse that helps with fine tuning is a multiverse where there's an infinite number of other universes and the laws and constants change between the universes. Yeah, so that's why, even if that's what we did, I think, in our second episode of our second season, we talk about many fine-tuned worlds is different than a multiverse. Scientists, to some degree, I mean, it's misleading when scientists say, well, quantum mechanics is evidence for a multiverse. Yeah, I mean, it might be evidence for that interpretation for a quantum mechanical multiverse, but it's nothing to do with fine-tuning. Because they just have an infinite number of ordered worlds. Big deal. The fine-tuned worlds, nothing to do with this. Doesn't solve the fine-tuning problem at all.
That's so interesting. Okay.
Yeah.
Okay.
Okay.
Cool.
We're getting back to the
The measure. Okay, good. Okay, the measure. Okay. The key thing there's basically this is now again. I want to emphasize there's nothing that we've said really at all that scientists wouldn't really agree with us. Everything up to this point except for God. Okay, that's the only thing. Everything else we're saying is they agree to what the constants of nature are. They agree with Feynman. There was a great mystery that all good theoretical physicists worried about in the 80s, and they agreed that fine tuning is a fact. It's a discovery. The numbers have to be within a certain range or in order for atoms and molecules and stars and life to exist. They agreed with that. They disagree that the proper inference is an intelligent cause because they say God is impossible. It doesn't make any sense. So they say therefore there's a multiverse, infinite number of other universes. The constants of nature change. They say that everything possible happens in other universes. They say that openly, and they say that the only way to and they say you need to predict a typical universe. They principle of mediocrity. They have that. They all say this, and they introduce measures, and they have what's known as the measure problem. They do it. They lay it out. They lay all this out. Our point is basically just to organize this, present it to people so people realize that scientists are saying this and explain the measure problem and to show why they're not coming back from this measure problem. There isn't going to be a solution. And let me explain it clearly why there's a measure problem going on for decades and they haven't solved it and they're not going to solve it. And once you understand the depth of the measure problem, you'll realize why multiverse is not a viable solution. Okay, the first thing to realize is measures are ad hoc. They're this arbitrary external thing that scientists are dreaming up this rule of how to count all these different universes in different ways in order to make different types of predictions of what is the typical universe. So Elie's example, in your mind, you decided, well, there's an infinite number of gold and silver marbles. Let me organize them in my mind, 10 silver for 1 gold. You could have made 37 silvers for 12 gold. Or 157 gold for 3 silver. There's an infinite number of ways you can organize the different universes. The multiverse isn't changing. It's the exact same multiverse. It's just the external ad hoc rule that a scientist is coming up with called a measure that's being imposed on the system that doesn't emerge from the laws of physics. No natural law of physics generates this measure. It's something that you have to introduce if you want to make count and create a probability distribution for an infinite number of universes. So that's the first problem. The whole idea of a measure is just this arbitrary meta law that's imposed on the laws of nature and in the multiverse in order to have it spit out a probability of what the typical universe is. Because if you don't have a typical universe, the whole multiverse falls apart because then it predicts dragons and unicorns and magic spells and voices from heaven. So you need a typical universe and you have to come up with a measure. Well, the whole endeavor of measures is flawed from its beginning. It's just this ad hoc thing that you have to come up with. That's the first fundamental problem with measures.
The second problem is let's grant that you can make up this thing called measures. So this is what physicists have been doing. They've been making up measures and they've been trying to find the measure which will result in our universe being a typical universe with intelligent observers in this infinite multiverse. And they've tried a bunch of different measures. Like one is like the volume measure based on like which one takes up the biggest size or in the space of all the different universes. And they've tried many different, dozens of measures. And all of them that they try don't work. It turns out that they can't actually, what do they call it, limit the freaky observers or tame the freaky observers or something. That the how do they call it? Boltzmann brain domination or whatever. And like whenever they do this and they check these measures, they don't work. It turns out that our universe is not mediocre. Our universe is not the typical universe. It turns out Boltzmann brains are typical. And therefore, the theory is that in order to justify multiverse, they have to show our universe is typical. Even if you grant them the ability to make up these measures, they actually don't end up working. They all result in the fact that our universe is atypical, which falsifies their whole prediction based upon this third premise of the typical multiverse assumption.
And it shouldn't be so surprising that if you just make up some random rule and figure out what's more likely, just by random chance, because again, all the things are all blind, unintelligent laws operating and just chance. That's physicists' whole dream, is to remove all intelligence from the universe and just end up with a purposeless, meaningless, blind universe. That's what they're working with. That's their goal, to explain science that way. So now, what is more likely? You're going to get through this blind, unintelligent process a universe with 100 billion galaxies, with each with 100 billion stars and planets and life and real human beings, or just a chaotic bunch of garbage with a random fluctuation of a brain which has all your false memories? That it turns out it's much more likely to get things like that than it is to get a really complex ordered structured universe. So shouldn't really be surprising that there are all these different problems. Multiple brain is one problem. There's other different types of problems that are just, if this is a real measure, some meta law that really is true, it predicts that our universe is not typical for various reasons. So that's the second problem. That the intuitive measures they've tried don't actually work. Okay, but they're still searching. They've been doing this for decades. They've tried dozens of measures. They don't work. And they're still hoping and searching that one day they're going to find a measure. And they need a measure. Again, because you need a measure because there's infinities. There's an infinite number of universes. You need to make typical. You need a measure. So they're hoping one day they're going to find a measure that they're going to say that's going to make our universe typical. And our point, and again, this is physicists themselves, the physicists who hates multiverse make this point. Paul Steinhardt does it very well, but it's that even if you one day find a measure and you say, wow, this measure makes our universe typical, we're real human beings after all, we're not just freaky observers, wonderful, throw a party. Yeah, but why is that the one measure that operates, this meta measure that operates on the laws of nature and multiverse, and that makes us typical? Why wasn't it one of the other 50 measures that you tried that you threw in the garbage bin because they didn't work out? Who chose that measure? Who designed that measure? Who fine-tuned that measure in order that this should be the universe that's typical? And you've tried to explain fine-tuning by making recourse to an infinite multiverse, which itself needs a designed and fine-tuned measure in order to make our universe typical. So it's just circular. It just begs the question of who fine-tuned the fine-tuned measure. So the whole thing is just, it's a bad idea to begin with because it's an ad hoc, artificial meta law imposed on laws of nature. The ones that they've tried that are somewhat intuitive don't even work. And even if they find one, it's not going to help them at all because it's going to be fine-tuned to design because all the other dozens of ones that they've tried haven't worked. And now this is the one. What explains that one? So the whole endeavor, the measure problem, is fundamentally flawed. It just doesn't work. And as a result of that, multiverse really is just a theory that has no real hope of ever becoming a scientific theory, ever really explaining fine-tuning without making recourse to this intrinsically flawed approach of measures. Yeah, go ahead. Yeah.
No, that's so fascinating. I mean, I think before you mentioned a word called the multiverse of the gaps. I like that phrase a lot. Like we spoke about how the constants were not the constants. Sorry, the fundamental numbers of the universe, so to speak, discovered decades ago, led to more and more scientific inquiry, which led us to discover that some of them actually just have to be that way. There's no other way around it. It points to something like an intelligent cause, like an intelligent designer, but it seems to be that science has gone, just from the way you're speaking, from what I'm gathering from what you're saying, it seems that science is so not married to the idea of an intelligent cause. It's so anathema to them to see God that they had to posit this notion of a multiverse, which causes the paradoxes such as a Boltzmann brain and these numerous amount of problems. Like, is it really just this anathema to God, do you think, that's driving science, or is there real scientific reason for it? And just they just don't want, and like God is just sort of separate.
Well, I think it's because the idea of God, they don't like the idea of God, but they have real questions about God. They say, who caused God? What does God even mean? Who fine-tuned the fine-tuner? We're saying that in order to explain fine-tuning, if you posit a measure that itself is fine-tuned, that just begs the question, because who fine-tuned the measure? But they say, okay, well, who fine-tuned God? Right? Your intelligent cause is God, that he made fine-tune the constants. Well, who fine-tuned him? Doesn't that beg the question? Why is God a better answer than a fine-tuned measure? You have to be able to answer who fine-tuned the fine-tuner. What would you say to that question? Why isn't that just a whole question on God? It's just circular.
I mean, to me, I think that there's the contingency argument where you have to have a necessary being for a contingent universe to exist. I personally am not like a sort of arguments for God type of guy. I've never really been convinced by one. But my ultimate answer would be that there must be something about the the ultimate cause, which is just unknowable by humans. And in a Maimonidean fashion, just like God doesn't know the way we know, God doesn't see the way we see, God doesn't, there's just a gap of language, and a gap of understanding which cannot be breached. And I'm comfortable with that. I know a lot of people aren't.
No, that's good. That's good. If my question to you was, who caused God? What caused God? So then You're right. There has to be something that doesn't have a cause. Physicists will say that's the laws of nature. That's the multiverse, the infinite multiverse that always existed, or the law of gravity, the laws of quantum mechanics. Those just exist. They're blind, unintelligent laws, and they exist, and they have no further cause. And we're saying God exists, and he has no further cause, and he made the laws of nature. And you're right, that's fine, but and therefore it would be inappropriate to argue there must be a first cause. It has to be God, because the first cause they're going to argue is the laws of nature. But the question isn't what caused God. Their question is who fine-tuned God. If our whole argument is that fine-tuning and design implies some sort of intelligent cause, so then what about God himself? You have to
meaning can you separate the fine-tune from the fine-tuner? Like, is the fact that those numbers represent the certain fundamental constants of our universe somehow attached to God as he is, or as God is, as opposed to like is there a separation between
who put God together? That's the question they say. God is this really super intelligent being who may fine-tune the universe according to us, right? This huge brain, this huge computer. So who put together all his parts so that he works well? Who arranged his brain so well that he's so super intelligent? Something must have designed God and fine-tuned God if his brain works so good to be able to make a universe. So who fine-tuned God?
Right. They call that special pleading, right?
Special pleading, yeah. You say fine-tuning implies a fine-tuner, but then when you get to the fine-tuner, you say God doesn't need fine-tuning. Well, why does his brain work so well? That's the question they asked us. How would you answer that?
I would say God doesn't have a brain. I don't know.
Exactly. No, that's the answer. That's the answer. Is that if you think God is a man, or really with a huge brain, or he's a supercomputer, a complex God with many different parts, then you're right. Then you run into that question. It becomes a begging the question, special pleading to say God doesn't require fine tuning. The only idea of God that this argument will point to is a God that's absolutely simple, with no parts, with no complexity. Yichud Hashem, the classic Jewish idea of Yichud Hashem. Muslims and Christians have had that too. Aquinas and Avicenna. It's the Abrahamic monotheism, true monotheism, that it's a God with no parts that isn't subject to the question of fine tuning. Where you can understand why, since God doesn't have parts, it doesn't make sense to say who put his parts together, because he doesn't have parts. So the only real idea of God that is a legitimate stopping point, where you're not introducing some arbitrary thought taboo and say you can't ask that question, is the idea of an absolutely simple God with no parts. Then you can't say who fine-tuned God. That makes sense. But scientists don't understand it. They always think you're arguing for a complex God, a human being, something with a big brain, something like that, and then they have this question. So to answer your question, why don't scientists understand this? Because their idea of God is very unsophisticated. It's childish. They have these questions, serious questions, but a non-sophisticated idea of God that they think these questions are attacking. And they don't have a deep idea of monotheism. In true monotheism, not just the idea of one God, but one God with no parts, one from all angles, that is able to stand up to these types of questions. And that's what we do in our third season. Our first season is about fine-tuning and design and order. Our second season is about the multiverse, showing why it's wrong. Our third season, we haven't released it. It'll probably take us a couple of years to develop it. We're slow workers. Is all about God and showing how to answer these questions from the framework of science using the categories of physics. The ideas of how physics deals with fundamental properties in the universe, the right categories, and to show that when you transfer those ideas to metaphysics, to the idea of God, you can really answer in a satisfactory way all the questions that scientists have about God. And that's our entire third season is really going to be devoted to answering these questions that physicists raise against the idea of God.
But I just want to add one point, is that if you take it as a premise, as these physicists explicitly do, some of them, that God doesn't exist, that's like a first principle, that God doesn't exist, then the discovery of fine-tuning is so amazing that the only way to explain it is to posit infinitely many universes where everything possible happens. And that's what's amazing, how it shows just how powerful the argument from fine-tuning is. If you start with the premise God doesn't exist, then you end up with infinite universe with all the craziness of it. If on the other hand, you start with the possibility that maybe God does exist, well, then fine-tuning points directly to him. And the only other way to explain him is with an infinite multiverse. So the fact that physicists who deny God out of the gates are jumping in and all hanging their hat with an infinite multiverse is an indication of the strength of the argument of fine-tuning and how fine-tuning really does point to God if only you're willing to accept that as a possibility.
That's fascinating, right? I really like that. It's like you can easily shoehorn God in, and not as a God of the gaps, like it's just the direct point to God.
Right.
And like if not, you have to concoct such a complex theory, which itself lends such complex problems that you have to spend decades and possibly never, if ever, figuring out.
Right.
It's so interesting, right? Well, I mean, I got us. There was I had a list of questions to go through. You implicitly answered all of them, and so it's fine that we didn't do that. I really like this back and forth, but I do always I just think it's important to end from the philosophical, the abstract, even the scientific and concrete, to the pragmatic. So you conclude that if we're serious about science, we must be equally serious about following the evidence wherever it leads, even if it leads to God. So practically speaking, how could accepting the fine-tuning argument, which points to God, reshape the way the average person engages with faith and God in the current age? How would it shape the scientific arena to treat this universe as unique and not one in an infinite series of universes?
I think really when you try to take this to real life and to how it really impacts a person's worldview and their life, obviously the idea of God and knowing that God exists can be a foundation for religion, and you can build upon that. But maybe you can talk about that. But one thing I think that the whole argument does is it brings in purpose into the universe. And the scientific framework that's been around for the past 200-300 years, it really has rendered the universe this meaningless, purposeless universe where teleological causes, purpose-driven causes don't exist. Everything is just this mechanical, materialistic universe. And when human beings search for meaning and purpose in their lives, they're told by science that that's just a wish that you are dreaming up within, a desire that you have in order to satisfy some psychological desire you have, because meaning and purpose have no objective basis in reality. They just stem from a instinctual wish that you have. But what this argument does is it shows you that at the foundation of reality, the fundamental constants, the laws of nature, they have a purpose. And the purpose is built into the universe itself, where the laws of nature are their way in order to produce a certain result of a complex universe. And it shows you that the universe is founded on an objectively real purpose. It has it baked into it. That gives the ability for a person to ground, to search for what could be their purpose in the universe. Do you have a place in the universe? Maybe you have one personally, maybe you don't. You have one as part of a grander plan that the creator has, but it justifies and gives a logical foundation in objective reality for the idea of purpose and meaning that has really been lacking in the modern world. Without this argument and seeing the design and the fine-tuning within nature.
And just to add to that, just to answer, I guess, your second question is how it affects the scientific endeavor, is that this is the in a certain sense, modern science thinks that they've overthrown the whole idea of purpose or of teleology. And the idea is modern science tries to explain everything based on efficient causes. And if you limit yourself to that, you really end up in the speculation of an infinite multiverse. And in our opinion, you waste decades and decades of manpower of trying to search for all the mathematics of this multiverse, which is just made up because you're not willing to recognize the idea of purpose and the idea of teleology. And we're saying is that the realization of fine-tuning and how it points to God and how God actually is satisfying is going to open up the door for science to realize there is purpose in the universe. And you can explain things when you get into the foundations of our universe. it points to a cause, and a cause with a purpose, an intelligent cause. And that doesn't mean you shut down all the rest of science, but it could affect the way that we do science. We should look at science, see the beauty of our one universe, see the wisdom which is implanted in it, and try to study all the amazing things which science gives us. But don't close our eyes to theology and to purpose, and thereby search for this endless quest of infinitely many universes, which are all based upon this assumption that purpose has no place in the scientific endeavor.
Right. I just got one more thing. Is so much
Of course.
People have like this idea of scientists. They are brilliant people, and they're rational. They are rational, brilliant people, and they attack God and they attack religion. And it's like we encourage people to listen to our podcast, go watch on YouTube. Explain that you'll learn a lot of physics. You'll see the argument. But like what you have to really do is watch these scientists. Watch the top physicists in the world, and they make videos for popular audience. Look at them say that they believe in infinite number of universes where everything possible happens, and see them say this. Read their words. When they do this, they have, it might be not accessible to most people, but they have mathematical, sophisticated, advanced articles and literature about the multiverse. And when you see that these brilliant people are saying something like that, it just can give a person a little bit more confidence that these are the same people who are telling you your religion is stupid. They're the ones who are saying God is stupid. And then you see what they believe, what they think. It really can give a person a certain amount of confidence that maybe these geniuses, where they are geniuses, but look at what they're believing in. Maybe I shouldn't be so quick to rely on their authority in areas of philosophy that are outside, a real scientific area where you can really have testing and empirical observation, things like that. And you shouldn't just be so quick to doubt your religion because of somebody who is saying something that's outside the realm of their expertise.
That's a great point. I mean, just to tie in two final thoughts, which I think relate to exactly to what you said before. The Rambam in his Hilchot Yesodei Torah writes that what is the way to know and to love God? It's to study his creation, to really become enamored with his works. If science took that approach, I think we'd be better off for it. Right? Like there would be more unity. And to your point about people speaking outside their area of expertise, like, yes, scientists, I agree that they're rational and they're very intelligent people, but I also agree that, their comprehension of theology is just not there. Like it's not, and it's not necessarily their fault. I feel like a lot of people are very confused about what God is. I'm sure Richard Dawkins is a brilliant biologist, but like when I hear him speak about God, it's just like, who are you actually talking about? Like, I don't know what you're actually speaking about. And I think there's a famous line, just to end off on this, or I'll let you end off. Rabbi Noah Weinberg, I think, might have said it. But he says, the same God that you don't believe in, I don't believe in. Like, that's a great little line. But I want to thank you very much for coming on. I will link Physics to God, a brilliant podcast and YouTube channel, in the episode show notes. Also, Rabbi Feder has a very interesting 2 books out, not related. One of them are called Happiness in the Face of Adversity, which is inspired by Rabbi Feder's mother, I believe. Yeah. And the other one is Gematria Refigured. So for the Jewish listeners in the audience, Gematria, they know what that is. For those who are not familiar, Gematria is the system in which the alphabet has corresponding numerical value. The Hebrew alphabet has corresponding numerical value. Very, very debated topic in the Jewish sphere, and Rabbi Feder has developed a novel way of approaching it. And Rabbi Zimmer, Rabbi Feder, thank you for all these fantastic explanations. I'm sure you saw in my eyes, I was just like listening to you, and like light bulbs were going off. Maybe they were the Boltzmann brains, I don't know, but like every 5 seconds, I was like, wow, that's really, really interesting. And I'm just so indebted to your podcast. I wish I had it growing up, but I'm glad it's here now.
Sure. It's been our pleasure.
Yeah, we appreciate that. We appreciate those thoughts. We're glad you enjoyed.
Of course. Thank you. And looking forward to seeing season 3.
Great. Thank you.
For sure. Okay. I'll see you. Thank you.
Have a great day. Hello, and thank you so much for tuning in to the Philosophical Jew podcast. If you enjoyed this episode, please like, share, and subscribe. I have spent many months creating Philosophical Jew, but nearly a decade preparing for it. In addition to the Philosophical Jew podcast, there is also a Substack. The Substack is a platform I use to write on various topics in Jewish and regular thought in the world. topics such as philosophy and theology primarily. If this interests you, check it out at philosophicaljew.substack.com. Additionally, you can find me on Instagram at a philosophical Jew, and on X as a philosophical Jew, and on Spotify for the audio versions, and on YouTube for the video versions of the podcasts. Occasionally, I do reaction videos, and have a few more coming up. If you enjoyed this content, please consider supporting me on Patreon. The link will be in the description. Have an amazing day.